Hello, everybody. This is Miss Elizondo, and this would be your video for your science notebook update. This is week 3.2, and it's all about rocks. Okay. So, what I want you to do is get your science notebook out and see if you have your vocabulary words for the first page for week 3.2. So, if you notice on your syllabus has 18 words. Okay. But I chose the seven most important ones that you absolutely have to know. And then we chose the other ones to be in pictures. Okay. So at the top, I wrote formation of sedimentary rock. So that's what you have to be learning this week. So, how does sedimentary rock form? Okay. Also, how do fossil fuels form? So the first thing you have to know is about weathering. Okay. Weathering means the breaking of rock that happens first. So the W is for weathering. It happens first. It's a process the rock goes through. Okay. Then it has to move or it has erosion. It goes through erosion. It erodes or moves. And that's the second process it goes through. Okay. So the E is for erosion. Deposition is when all the pieces of rock break and fall. Okay, they fall or drop. They drop. So the letter D is for deposition. That's the third process it goes through. Okay, once they drop, they land like in layers. Okay, so you have the bottom layer, the next to the bottom layer, the top layer, and it is like cement. That's why you have cementation. It's when all the particles or all the cement, all the rocks, all the rock pieces bind together. Okay, they're coming together and it looks like cement. Okay, why do they come together? It's because of compaction. That's the pressure from the earth. It's pushing down on these layers of sediments or pieces of rock. And when they compact, they look more and more like cement. Okay. So I have a rock here that's a sedimentary rock, and you can see all the layers of this rock. Okay. And it feels like cement or cemento. It's super heavy, super hard. Okay. So this went through weathering, erosion, deposition, compaction, cementation. Okay. How did it stick together like this? Well, minerals inside that rock, it's like the glue that hold the pieces of rock together, and they look like crystals. Okay. So I have some minerals here. Okay. I have a rock, and you can see that there are shiny or glistening. Okay, those are like crystals, and they are the minerals that bind these little sediments or pieces of rock together. Okay, so the last one is sediments, which is just pieces of rock. And then we have three types of rocks. We have igneous rocks that when they break up, they become sedimentary rock through layers, layers, and layers, and layers. And then those sedimentary rocks break, move, and drop, and they can become metamorphic rock if this is next to or close to something really, really hot, like the magma of the earth. Okay. And then the metamorphic rock can also go back to the magma, and once it comes out, okay, it comes out and forms igneous rock, and then it just keeps happening over and over and over again, and you have these three types of rocks. Okay, so on the second page I have the process of the rock cycle, okay, which is better explained. So what I did is I wrote the title, The Rock Cycle, on the very top, and I drew the volcano. Like half my page is the volcano. Okay. And it's very important to let's look inside the volcano. Okay. So inside the volcano, you have magma, and that is boiling and super duper duper hot. It has a lot of energy inside. It has to go somewhere. So the volcano will erupt. Okay. It'll erupt, releasing some of that energy, and it releases the magma. But once it's out of the volcano, it's lava. Okay. Then the lava runs down the volcano and it starts to cool. Okay. It's not as hot. So when it cools, it produces igneous rock. Okay, so igneous rock will break, move, and drop, or it'll weather, erode, or deposit by wind or water, gravity, ice. So here are the little sediments or pieces of rock, and they fall in layers. So this layer fell here to the bottom, then another to the bottom, and then you have pressure, compaction, squeeze, squash, compact, and then it looks like cement with layers. It looks like this. Okay. So inside those layers, you can also have a plant or two from 65 million years ago get squished, squashed, compacted, and cemented within those layers, and you have fossils. Okay, so the sedimentary rock is a fascinating rock because it could have fossils and it could have fossil fuels. So I have coal right here. Okay. So this coal was found in sedimentary rock. Okay. And we take this coal, which is old dinosaur plants that have been squished, squashed with a lot of pressure for over 65 million years. And what humans do is they dig into this rock or into the earth, find these fossil fuels, which is coal, and we take it to a company that will burn it. Okay. That Magic Valley electric company will burn it. And those fumes or that smoke that comes out of this coal, which can burn a long time, will spin. Okay. Will spin a turbine like a fan looking thing, and it'll store the electrical charge. Okay. And that's what is sent to your house through those power lines, and that's why you can turn on the light in your house. Okay, so we're actually burning a lot of coal so that you can turn on the light at your house or charge your phone. Okay, so where do we get this coal from? Sedimentary rocks, and we also find fossils here too. So I drew a little bit of fossils here. Okay, then you see these letters here. L is for layer, layer. F is for fossil, layer. Then I squeeze, compact, and then there's cementation, but I don't really need heat to form a sedimentary rock. Okay, so sedimentary rocks don't really need heat, but they need a lot of pressure, a lot of compaction, a lot of cementation. So when a sedimentary rock breaks, it can also break into places where it's really, really hot inside the earth. Okay. And they do break and they form layers. So you see that I have red lines here. That means it's hot. Okay. So when you have sedimentary rock breaking up into pieces, okay, and forming layers, but you still need heat, it'll form metamorphic rock. Okay, so metamorphic rock needs heat to be formed. Sedimentary rock does not. And of course, igneous rock, yeah, it was hot, it was cool lava. Okay, so if this metamorphic rock goes back into the earth, into the magma, then the rock cycle starts all over again. Okay, it starts all over again. So metamorphic rock is then melted down into the magma. It becomes liquid rock in here, very hot, and it comes out as an erupting volcano, and you have lava again. And then the rock cycle begins all over again. Okay, so that's how the three rocks are formed. So then I go to the next page. Okay, the next page is our lab for Thursday. Okay, so our lab is about weathering on Thursday. So you're going to need a cookie, a jar. So I have a jar right here. I have a peanut jar that my husband loves to eat peanuts. So I have these jars. Okay. I used Famous Amos cookies, chocolate chip cookies. Okay. You can use whatever cookie you have at your house. Okay. This experiment, it lends itself to whatever cookie you have at your house as long as it fits in the jar. Okay. So, because you're going to need a lid to put the cookie in, and it has to fit in there. Spaghetti jars are pretty good too. They're just, some of them are glass. So you got to be careful with a glass jar. Okay. So, what do we want to find out on Thursday? We want to answer this question. Okay. How long will it take for a rock to weather or to break? Okay. Our hypothesis in fourth period was 99 years. I copied one student. Okay. So you can determine how many years you think. That is your hypothesis. Okay. Also, we're going to do some observations. Okay. We're going to draw the cookie, what it looked like before you put it into the jar. And then what does it look like after you have shaken the cookie in the jar? Yes, you're going to shake it. Okay. No, shake the jar, not you. So you're going to keep track on how many shakes you did. Okay. So you're going to grab that jar with your cookie in it and you're going to shake 1, 2, 3. And you're going to see or observe, did my cookie break? So if it broke in 3 shakes, you're going to have to write the number 3 here. And I will tell you on Thursday, well, what does 1 shake equal to, miss? Is it 100 years? Is it 10 years? Is it 5 months? What is it? Okay, so keep track of the shakes and then I'll tell you what they're equivalent to. Okay. Then, of course, we have the analysis. After we do the experiment, we're going to analyze, well, what happened? Were you completely wrong or completely right? Why or why not? Okay. On the left side, after the experiment, you have a lab report. Okay. That lab report, you must write what happened in your lab and you have to incorporate these vocabulary words in your paragraph. Okay. So if you want to work smarter, not harder, yes, you can use 2 or 3 words in one sentence as long as it makes sense. Okay. So one great paragraph explaining what happened in your experiment and what went right, what went wrong, including these words in your lab report. Okay. Then we're going to go to the next page. Well, what makes a rock break? Okay. So we have 5 things that could possibly break a rock, move a rock, or drop a rock. We have 5 things that could possibly weather the rock, erode the rock, or deposit the rock. Weathering, erosion, deposition. Okay. So one of the agents is wind. Okay. So I wrote the word wind like wind. Okay. So this is where your art comes in your science class. Water is another agent. Water can break a rock, move a rock, and drop a rock. Okay. Waves, like in the ocean, you're constantly breaking shells. Okay. So waves can also break, move, and drop rocks. Ice also can break, move, and drop rocks. And of course, you see this black line towards the middle. And how did I get it so straight right in the middle? I just folded my page in half, opened it up, and I traced the center line with black marker. And at the very end, I put an arrow. Okay. Gravity can also weather, erode, and deposit rocks, or it could break, move, and drop rocks. So this is week 3.2. It's all about rocks and how they're broken, how they're moved, and how they're dropped. Also on sedimentary rock formation and how fossils are formed in that rock. Also how fossil fuels are formed in that rock. So I have agents of WED, my lab report on the left side. Okay. I have my volcano so I could see exactly how these rocks are formed, the rock cycle. And then I have my vocabulary words, not all 18, but they're all in there somewhere in all those pictures that we drew. Okay. I hope this helps you update your science notebook for week 3.2. Thank you.